Thank you very much. Thanks for the invitation to come to this event. I was very pleased to hear from Brenda and have the invitation to come and talk about this site and some updates. And yeah, it sounds like it's been a couple of years since we've shared news. So again, my name is Freyja Knapp. I'm with EPA Region 9 in the San Francisco office, and I'm the point of contact for the Leviathan Mine Superfund site. Oh, this was gonna work. What's working? Oh, I'll scroll. I think that's okay. There we go. Okay. All right. So this covers the topics that I'll discuss today. So I'll give some introduction and background. I'm sure there's some of you in this room that are familiar with the site, and there's probably others that don't know much. So I'll give you sort of a big overview of the history of the site and the work that's been happening over the last couple of decades. And part of that will be the ongoing early response actions that have been implemented. I'm also going to touch on a success story at the site, or the work that shows the evidence of the success at the site so far, biomonitoring and stream health data. And then I'll conclude with a little bit of what happens next. And there's actually a fair amount on in the near future. There's a lot of activity at the site. So here we have a map on the left showing relative location of the mine. It's down there in green, labeled Leviathan Mine. It's about 25 miles southeast of Tahoe, and it's about 7,000 feet elevation, give or take. You can see the mine there on the right in that image. And if you go to Google Maps, you can find it. It's a pretty big site, and it's very visible, especially since there's really very little tree cover on that site. So the history of the site, it was operational for just about 100 years, but it was only periodic during that time. And there were kind of different phases of mining at that site. So early mining focused on underground mining for copper in the 1800s. And then in the last century, it was used for a source of sulfur. And first operations were underground, and then in 1952, instead open pit mining was conducted, which really dramatically changed the landscape. So overall, there's about 250 acres of disturbed areas. Most of that land is owned by the state of California. Some of it is U.S. Forest Service. In all, there's about 22 million tons of waste rock, overburden and sub-economic ore, which is kind of a number that is really hard to get your mind around when it gets that big. What does that even look like? Let me tell you, it's big. I visited the site in January, and much like an earlier presentation, I've only seen the site under snow. It looks very peaceful and beautiful. But as people were pointing out things, you say, yeah, that's overburden. Oh, yeah, that's the mine waste. And I thought they were just the peaks of the mountain. They're big piles. There's two responsible parties. Atlantic Richfield Company acquired the liability from prior operators, and state of California as landowner is also a responsible party and conducts work on the site. So one of the high priority issues of the site is acid mine drainage. More broadly, there's a phenomenon called acid rock drainage. And without digging into a lot of the details on the science, when you get rocks that have, or ore that have minerals in them, certain minerals, particularly if there's sulfates, and you mix that with oxygen and water, you can get a chemical reaction that produces acid. And that acid can then get other metals into solution, from solid state into a solution, and then that can flow into streams and whatnot. So that's a very high level acid mine drainage, and that is something that we pay attention to on this site. So there are 5 primary sources where acid mine drainage or mine impacted water emerge on this site. And you see them in the orange dots. And I also recognize this is a 2-dimensional view. It's very different when you're on site because there's actually there's some words there that says waste rock, and the aspen seep up there is kind of up over a hill. So it's not like you're sitting on a big flat area and you can just see all these sites. There's a lot of topography here. All 5 of these sites are currently captured and treated in 3 different systems, 2 of which are year-round capture, and 1 of which is seasonal. And I'll talk a lot more about those. So here we have that same image on the right that we saw earlier. And if we orient ourselves almost 180 degrees and look down, you see the map on the left. So we've got different treatment areas. I know it's a very busy map with all the words, but hopefully you can kind of remember where those different sources were. There's the aspen seep way up there on the right-hand corner, and then down on the left, this is a lot of area of activity. So big former pit, there's some retention ponds, and then there's a couple of different sources at it, and some places where culverts emerge, water emerges under culverts, and then there's a seep down there. So this area down in the lower left is basically the large amount of industrial activity at the site. Okay, so as I mentioned, there have been ongoing early response actions at this site for multiple decades now. And so we have the map again on the left to orient you with those different sources in orange. And the timeline over on the right, those arrows and the orange text align with when those different responses started getting implemented. So the Leviathan Regional Water Quality Control Board, state of California, has been active on the site for a long time. And they implemented first the pollution abatement project. And then about, what is the math? About 10, 14 years later, they started treating with lime. Just before that, there was a project up at the Aspen Seep, first implemented by the Leviathan Water Board. And then subsequent to that, the site was listed on the national priority list in 2000 as a Superfund site. And shortly after that, Atlantic Richfield then was at the table, and they started implementing remedy in a couple of the other sources. So talking about kind of each one, here's some pretty, I think, helpful images. You see over on the right, that is a picture from about 1983, and that's Leviathan Creek, which has made its way back through a whole lot of overburden that was dumped on the creek when the open pit mining was occurring. And so you can see that the stream would very likely be impacted flowing through that at that time. So, you know, that's why the state of California took a lot of interest. They purchased the property in order to address water quality, and then implemented this pollution abatement project, where you see down on the right, they did a lot of regrading of the big open pit. They constructed retention ponds, and they channelized the creek so that it no longer had to flow through the mine overburden. So in 1996, they initiated a project in conjunction with University of Nevada, Reno, piloting a bioreactor at the Aspen Seep, that one spot that was up in the right-hand corner. It's currently now operated by Atlantic Richfield. And this uses slightly different technology, but the idea is you neutralize the pH and you add a little, you know, helpful food for the bacteria, and then they do a lot of work to bring a lot of those metals back out of solution and into a solid state. Again, I mentioned that earlier on that timeline that Leviathan Regional Water Quality Control Board implemented lime neutralization in the pond water. So here you see one of the ponds and their equipment over on the right that stores a lot of materials. And when this is covered in snow, you have no idea what's underneath. Okay, and when Atlantic Richfield came to the table, we engaged them in a legal agreement to conduct response action at the remaining major sources of mine impacted water. And so here you see a picture of their facility. So first they implemented lime neutralization, and then a few years after, they constructed and started running a high density sludge treatment system. And in that case, these HDS systems, you are still using lime, but you also add flocculant. You're kind of mixing it all up. And as things solidify, it will create this very high density sludge that's very stable. Some of it gets recycled back into the system to keep using what lime is in there. But then it kind of reduces the volume of what you have to transport after. And all of the sludge on the site is currently transported offsite to a facility in Nevada that's able to take those materials. Okay, so here we have a great summary total. For anyone who's interested, I have a fact sheet out in the front. It does have this table. However, you all are privy to the most updated numbers here on the slides. So the table in that fact sheet is a few years old, but these are the most updated numbers up through 2021. And so again, these numbers are so big, it's hard for me to get my head around them. And I should have done the, like, how many swimming pools is that calculation? And there's probably people in this room who can do that, like, on the fly, because I understand there's a lot of engineers in here. But there's, you know, almost 400 million gallons of water that's been treated since 1999. So that's pretty significant. It's a big site. And then you see, you know, the pounds of certain metals summarized here that have been removed. So now for a real story of success. So for over 20 years, there's been a partnership between EPA and the University of California to conduct biomonitoring along the creeks. And so the map on the right, the colors are a little hard to read, but you can see the Leviathan mine at the very bottom, kind of a beige color with a purple outline. And then there's some yellow dots, and those yellow dots are locations where they've gone back year after year after year and conducted sampling to see what the stream looks like and what the bugs look like. So those results up to a certain point have been published in a journal article. That's, again, sorry for the small text, but I feel like even when you read the journal article in front of you, it's small text. I find it as not a bug and water scientist. I still find it easy to understand, but it's a great story of success. They've got some nice charts in there, and it really documents and describes the whole process that they've gone through. So I can't not put a chart or two in here. This is one of the results from the study. So I'll walk you through it because both the text is small, but the chart is also kind of interesting and unique. So on the vertical axis, it's the log sum of the cumulative criterion units for metal toxicity. So basically think of it as a measure of the loading of metals in the water. And then along the x-axis, each one in between those tranches, those long vertical lines, is a location. And then within that, it's a span of years. So it starts at 1998 and goes to 2015 for each one of those divisions. So you can see that there's an overall trend at these different locations, generally speaking, of metal loading decreasing over time from 98 to 2015. There were a couple of high discharge years in this particular data set. So you see a couple of spikes in a few of those that do correlate to those high discharge years. And then the red circle in the bottom corresponds to the location, the red circle in the top map. And I like that location because that's the confluence of Leviathan Creek at Mountaineer Creek. So it's still downstream from the mine, but it's a fair distance down from the mine. And so that particular set of results, I think, is a really great story of high metal loading in 1998 to much lower metal loading in 2015. So another measure of success by the same collaboration is the health of the creatures living in the stream. And in this case, they're monitoring, I'm going to say bugs because I'm not a bug scientist. I'm sure somebody said they're not true bugs. But they are looking at the different taxa that are living in the stream and doing counts. So the charts there in the middle, again, everything's pretty tiny, but the x-axis is time, and the y-axis, both are measures of the amount of these animals in the stream. So we have on the top the average number of taxa or animals, types of animals, and the bottom we have the mean number of EPT, which are particularly sensitive species that they're paying attention to, which are a nice marker for, if the really sensitive ones are recovering, then, that might mean that everything else has a better chance too. So they measured both, they separated those out. And we see that there's a general trend upward. So there's more and more of these types of creatures in the stream and more of these particularly sensitive bugs in the stream. I want to mention, though, that there is a pattern that correlates with a seasonal relapse where those numbers drop again. And that coincides with the end of the seasonal treatment. Remember, I mentioned that one of those responses is only a seasonal operation. And so we do see evidence that there is still an impact from that response because it's only part of the year. And one more last little bit of evidence. We see pictures on the right showing in the upper one, the colors are a little hard to see again, but I'll point out what to pay attention to. This is the confluence of Leviathan with Mountaineer. And so on the very sort of center top part of that top image, the stream Leviathan is brown, kind of brown looking. And if you look at the same spot down below, there's less water because that's during the summer seasonal treatment, but the water's no longer brown. Okay, so what happens next? Are you all familiar with Superfund? Who's even heard of Superfund? Okay, fair amount, great. So Superfund process generally goes, it looks like it's this very linear process of like, you're gonna, find a site, you assess it, you list it, start studying it, you make a decision, there's a lot of public comment and all of that, and you start implementing a remedy. One thing to highlight is throughout this, community involvement and stakeholder involvement is critical. And with this particular site, we have a government-to-government relationship with the Washoe Tribe of Nevada and California, because they have a distinct interest in this site. What this chart doesn't show is that Superfund is flexible enough to respond to the site conditions. So like I said, there are all of these other earlier response actions. And so we can do that on a site if we need to intervene earlier before we get to that really big, we've studied the whole thing. And some people, have a lot of concerns around that. Superfund can take a long time to really complete, but that doesn't mean that we don't take actions along the way. So on the horizon, we have options to look at and decision making, and it's split here into two columns. Over on the left, this is called an early final remedial action. And what this is focused on is year-round capture now of that acid mine drainage, the mine impacted water. So remember all those results, it looks great except for that seasonal flux. So this set of options and decision-making that we have coming up is meant to address that. And on the right, this is the really big, okay, we've studied the site. Now let's look at all of the rest of the things that are going on in the site and think about options. We won't get to the decision making quite as fast because it's big and we're not quite as far along, and our priority is that year-round capture. So again, the focus is year-round capture and treatment of acid mine drainage. It's using information, lots of evidence showing that this should be successful. The public are invited to comment on the proposed plan when EPA issues that. And EPA will respond to those comments and then issue a record of decision. And then once that happens, EPA and the responsible parties will engage in negotiations to set new legal agreements for the parties to design and implement the selected remedy. Additional activities coming up this year. So we're also updating the community involvement plan. And those plans are basically a documented commitment of how EPA is going to communicate with stakeholders in the community. And in order for that to be successful, we are really interested in anybody who wants to participate in interviews with us about those things, questions, concerns about the site, how folks want to be communicated with, how they want to be engaged. So please come and see me if you're at all interested. And I'll also be reaching out to those that I know that are already on the list. But if you're not sure, come and talk to me. And then we're also hosting a technical meeting for stakeholders and interested parties. There's a flyer up front. It's a virtual meeting, about 4 hours. It's going to be pretty technical. So if you're interested in those technical details, it should be pretty interesting. So everyone's invited to that. There's a registration link on that flyer. And then it'll be a Zoom meeting. So thank you very much.